All right, this lesson is coming from section 6.4, and the exercises are on page 461 and 462. Before we start the exercises, I want to look back at the handout that I gave you in the last lesson, because part of this refers to section 6.4 as well. Right here, these are some reminders that you're going to need as we work through some of the problems. This is some stuff from the past. Good review for the final. That a to a fractional power, the n, the denominator, tells you the root, and the m tells you the power to raise it to. And that m can be moved inside the radical and go with the a. So that's what we do with fractional exponents. And the way we're going to be going at it is going from here back to here. So you'll need to remember that the denominator, the root that you're taking becomes the denominator, and the power becomes the numerator. Also, I need to remind you that when you have a number raised to a -1 power, it's 1 over that power. Okay, so this lesson introduces logarithms. And we first need to know, what is a logarithm? Well, it's just an exponent. It's a way of writing a statement so that what it equals is the exponent. We abbreviate it log, but it means logarithm. And it says the log base b of x equals n. That's the way you read that. The log base b of x equals n. And when you want to change that to an exponential form, remember I said a logarithm is an exponent. So whatever the logarithm equals, that has to become the exponent. Whatever was the base of the logarithm will be the base of the exponential. And then x is equal to x. So sometimes we'll go from this form to this sum, and sometimes this form to this form. But what you need to keep in mind is just that a logarithm is an exponent. So what the logarithm equals, that has to be the exponent. Then I talked with you last time about the natural logarithms, about e. Well, I talked to you about e and not natural logarithms. But e is this number that's like pi. It goes on forever and ever. And it is the base of the natural logarithm. There are two bases of logarithms that are most commonly used. One is called natural logarithm, and we abbreviate that as ln, and it means log base e. The other one is common logarithms, and that means log base 10. So when its base is not written at all, the 10 is implied. And when it's ln, the e as the base is implied. And then later in the group, we'll look at how to solve a logarithm equation by rewriting it in exponential form. And we'll look at that in a little bit. All right, so the first group of problems we have is to change from exponential form to logarithm form. Okay, so we've got log. We're going to put something here, equals, and something here. So that's the way we're going to fill it in. I told you that what a logarithm equals is the exponent. So whatever the exponent is, that's what the log is equal to. The base of the exponential is the base of the logarithm. So we put 3 right there. And we've got one box left and one number left, so 9 goes right here. So it's written the log base 3 of 9 equals 2. And that tells us that 3 to the second power is 9. That's what a logarithm means. 2 is the exponent that goes with 3 to give you 9 for the answer. Alright, so for this one, our base of the exponential is a, so that'll be the base of the logarithm. The exponent is 2, so that's what the logarithm will equal because the log is an exponent. We've got one number left and one spot left, so we'll put 1.6 right here. Alright, number 15. The log, the base is 2. The exponent is x, so it'll equal x. And 7.2 will go right here. In this group of problems, all we're doing is just writing from one form to the other. We're not trying to solve for x or evaluate or anything. We're just changing from one form to another. Alright, finally in number 17, we have e to the x equals 8. So that would be the log base e. It's going to equal x because that's the exponent. And I just told you on that handout that log base e is written as ln. So this is the way we would write that answer. Log base e is not wrong, but this is the better way and this is the more accepted way. And this is the way the computer is going to expect you to do it. Okay, so that was examples of changing from exponential to logarithm. Now we're going to go the other way. We're going to change from logarithm to exponential. Now, if you have it written like this, the log blah 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 blah, I like to call it the wave. You start here, come around to here and there. 2 to the third equals 8. And that's the exponential form of that statement. So this one would be a to the 6 equals 3. Now, we could use the same kind of logic. The base is the base. What the exponent equals, what the logarithm equals is an exponent, and then 3 is what's left over. So this one would be 3 to the x equals 2. If you think of that like a wave, a swirl, it works. Now, natural log, remember that's log base e. So e to the x equals 4. And that's how we go from logarithm form to exponential form. Alright, now we're going to look at evaluating, actually finding the value of some logs. So in every case, we're going to be looking for an exponent because that's what a logarithm is. So you can ask yourself, what is the exponent that goes with 2 to give me 1 for the answer? What is the exponent that goes with 2 to give me 1 for the answer? Well, you'll remember from our work on exponents, we learned that any number raised to the 0 power is 1. So if we want the answer to be 1, the exponent has to be 0. Now, you can do it like that, or you can put equals x and then change it to exponential form, 2 to the x equals 1, and you come out the same way. So it depends on how you want to think about it. This one you could say, what is the exponent that goes with 7 to give me 49 for the answer? And most of you would know that's 2. But if you need to see it worked out as an equation, you would do 7 to the x equals 49. And you remember last week when we learned to solve exponential equations, we said you have to make the bases the same. So I changed 49 to 7 squared. And when the bases are the same, you can make the exponents equal. So x equals 2. Now, this one, number 31, is a little more difficult to think about it in terms of what is the exponent. So I think it would be easier for this one to do it like that, make it equal to x, and change it to exponential form. Now remember, we had on the bottom of this paper, when you want to solve a log equation, rewrite it in exponential form. That is most often the way we're going to do that. So I'm going to write 1/5 to the x power equals 125. Well, I don't have a common base, but I have to have one in order to solve it. And so remembering this little rule right here, that 1/5 is 5 to the negative 1, I can change 1/5 to 5 to the negative 1, and I can change 125 to 5 to the third. When you raise a power to a power, you multiply the exponents. So this is 5 to the negative x equals 5 to the third. Therefore, negative x equals 3. Multiply both sides by negative 1, and x equals negative 3. Now, I do need to mention two things. The base of the logarithm can never be a negative number, and this is called the argument. The argument can never be a negative number. What it equals can be negative because that's an exponent, and exponents can be negative. But the base and the argument, those two numbers can never be negative numbers within logarithms. All right, now we're on number 33. Well, I've just got log nothing. Remember, if there's no base written, it's understood to be 10. So I'll make that equal to x. So 10 to the x power equals the square root of 10. Well, I need that written as an exponent rather than a radical. That's an understood 2 because it's square root. And that's an understood 1 because it's the first power. And so according to the rule on this handout, if it's 2 and 1, that becomes 1/2. So 10 to the x equals 10 to the 1/2. 1/2, that's how I get that. Therefore, x equals 1/2 because the bases are the same. All right, number 37. I'll make it equal to x. Ln, remember that's log base e. So this says e to the x equals the square root of e. By the same reasoning that we just used right here, the square root of e is e to the 1/2 power. Therefore, x equals 1/2. Okay. Now we're going to look at solving some log equations that are basically the same kind of thing. They just have a little bit more complication to them. So we're going to do 3 to the 2 equals x. I'm doing the same thing. I'm changing it from log form to exponent form. Well, what is 3 squared? That's 9. So I'm through. I've solved for x. Okay, 2 to the 5th equals 3x plus 4. Well, 2 to the 5th is 32. I need to solve for x, so I'm going to subtract 4. And now I need to divide by 3. So 28 over 3 equals x. And that's my answer. That would be a positive when I plug that back in. Alright, x to the second equals 16. So we're going to take the square root. And normally, when you take the square root, you get both plus and minus 4. But see where this x is? And I told you it can't be a negative number. So we're only going to use the positive answer of positive 4. Alright, this means log base e of e to the x equals 5. So let's write it in exponential form. E to the 5th equals e to the x. Well, my bases are the same, so I can make my exponents the same. 5 equals x, and I'm through. Alright, 4 to the x equals 64. We recognize that 64 is 4 to the 3rd power, therefore x equals 3. Alright, number 99. 3 to this power is going to equal 243. Okay, this is your exponent. So 3 to the 2x plus 1 equals 243. Now, you have to recognize that 243 is 3 to the 5th power. So now the bases are the same, so I can make the exponents equal. So 2x plus 1 equals 5. Subtract 1 from both sides and divide by 2. Seven to the second equals this. Well, 7 to the second is 49. And when you're solving an equation with x squared that doesn't have an x, you can take the square root of both sides. And before you do that, you need to isolate the squared term. So I'm going to subtract the 4. And then I'm going to take the square root. Remember, we're not doing plus or minus. Well, yes, we are. Because when you square it, it's still going to be positive. So we do need plus or minus this time. Because when you square a negative, it's still going to be positive, and you add 4, you're still going to get a positive number. So then we need to prime factor 45. Good review for simplifying a radical is 3 times 3 times 5. So you pull out the 3 and it goes right here. So it's plus or minus 3 square root of 5 for my answer. Number 107. 2 to the negative 6 equals 8 to the x. 2 to the negative 6 equals 8 to the x. So my common base is going to be 2. So I change 8 to 2 to the 3rd. And 2 to the 3rd to the x becomes 2 to the 3x. Power to a power, you multiply the exponents. Now the bases are the same, so I can make the exponents equal. Divide by 3. And I get negative 2. Alright, let's see if that's going to work. X to the negative 2, 8 to the negative 2 would be 1 over 8 squared. So that is going to be a positive number, so that's acceptable. That ends this lesson.